Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutiwa Sos Ukobela Wemet. And without any further ado, let's look at these questions that we have here. Okay, so we have question 2. It says hydrogen cyanide, HCN, is a very poisonous compound used in the manufacturing of plastics, mining of gold, and as a poison. Then 2.1, it's saying define the term chemical bond. So to quickly rush to that, we say chemical bond is a mutual attraction between two atoms resulting from the simultaneous attraction between their nuclei and outer electrons, right? So for 2 marks, that's how you're expected to define this, and then pay attention to this definition, guys. It is very, very important that you know it. Then let's move to 2.2. It says draw a Lewis structure for HCN. Now, again, you can see the trend. After the definition, they require of us to draw the Lewis structures, right? And then having to draw this one already here, we can just make our carbon the central atom. So there we have our carbon like this. And then what I'm going to do now is that first I will draw the individual atoms. So we know that carbon has 4 valence electrons, and then we know that hydrogen only has 1 valence electron. And then that nitrogen, it's in group number 15 with 5 valence electron, right? So there we go, 1, 2, 3, 4, 5. Now we kind of want to get what actually happens with these ones here. So let me try to do a different color for the nitrogen. Then, okay, now we want to understand what happens. Remember, we want to draw a Lewis structure for this whole molecule here. So what we are going to do is that we understand that the hydrogen only needs to fill its orbital using 2 electrons, right? So the hydrogen only needs 1 electron from this carbon. Remember, this is where we're going to base our sharing from, because it is the central atom. So the hydrogen only needs 1, so it will have this 1 electron. But then remember, this one here has a lone pair, and then all in all, in total, it has 5 valence electron. In order for it to have a complete orbital, then it needs 3 more electrons. Where is it going to get those 3 more electrons? It's going to get it from the carbon here, right? So that means all this 3 here will be pulled towards this side, and then they just gonna line here vertically, and then also these 3 electrons will come here and then line vertically so that it forms a triple bond here. So you have to be careful with the hydrogen cyanide as to how it bonds there. So at the end of the day, this is now what you are going to have there. So we have our carbon with this 1 electron here, and then all of its 3 electrons lined up this side, and then which will line with these 3 available electrons here. This is 1, 2, 3. These ones, we cannot break them apart. They are lone pairs, right? And then on this side up, this electron reacts with this electron from the hydrogen. Now we can see that every atom here now has a complete orbital, right? So with the carbon, that's 6 plus this 2, that's 8 valence electrons forming a complete orbital. And then with the nitrogen, that's the 6 and the 2 here, that's 8 valence electrons. And then with the hydrogen, we only have this 2 here, which is, it's complete for the hydrogen since it only needs 2. Then basically what you are supposed to draw for the Lewis structure, it's only that part there. Right. So your solution is this one here. Nice. Then let's go to 2.2.2. It says now, draw the Lewis structure for H2O. Now for H2O, we have already drawn this a couple of times now. You should be able to draw it in your slip. So you have your oxygen, and then that's 1, 2, 3, 4, 5, 6, And then now we know with the ones that are available here, that's where your hydrogens will be attaching. So you have your hydrogen there and your hydrogen here. And then this one, valence electron of the hydrogens, right? And then just like that, it is now complete. You count the number of valence electrons around oxygen, there are 8 of them. And then on each hydrogen, that's only 2, right? So 2.3 is saying, what is the shape of the HCN molecule? Now, from the drawing of the HCN, we saw that we ended up having a single bond at this side with the carbon. And then this side here, we had a triple bond, right? So looking at this, we can see that this kind of gives us a linear shape, right? So this is just a linear shape. A linear shape. Now, 2.4 says calculate the electronegativity difference for the CN bond. So electronegativity difference 2.4, change in En. So remember, we have to take the bigger value minus the smaller value. So looking at our carbon and our nitrogen, we can see nitrogen is at 3.0, but then carbon is only 2.5. So we must say the En of the nitrogen minus the En of the carbon, right? And then there we go, we have 3.0 minus 2.5, which will give us 0.5. Now, if they wanted us to comment on this one, we would say this is a weak polar covalent bond. But then we were not asked to comment on that. So let's move 2.5. What is the polarity of the HCN molecule? Right, only polar or non-polar, right? Now, for the HCN molecule, obviously considering how the bonds are here, we can see that there's an uneven distribution of the electron density, since we can see that this side up here will be more electronegative than this side here. So this makes it polar, right? So we have to say polar. Then the table below indicates the values of the bond length and the bond energy. So every time you are given this, you have to figure out what is the relationship, right? So we already discussed the relationship from the previous question. We said the bond length is inversely proportional to the bond energy. So what we are expecting here is that when there is a longer bond length, there is a smaller bond energy. Then explain why the bond energy of the CN bond is more than the bond energy of the CH bond. Now let's look at what we have here. Looking at this 2 here, we can tell that a greater bond length is on this one here, and then a shorter bond length is on this one. But then we can see that that does not really match up with our relationship here, right? Because obviously we are expecting that since this one has a shorter bond length, then it must have a higher bond energy. And since this one is a greater bond length, then it must have a lower bond energy. But then it seems like that relationship is not consistent here. So now we want to explain. So this question is really about explaining why that is the case. Why is it the case that we know that bond length, this is a fact, by the way, we know that bond length is inversely proportional to bond energy, but then why is this relationship not being respected here? So we're going to have to check and then find out that, remember, the CN that we are talking about here, it's all the way from here, right? Remember, the CH and the CN has been taken from the HCN. So they're saying the table below indicates the values of the bond length and the bond energy of the different bonds in HCN. So remember, with the HCN, we had a single bond here, and then we had a triple bond between the carbon and the nitrogen. So now, what is really affecting our bond energy here is not the bond length. It is what? It is the bond order, right? So the reason we see this one, even though it has a greater bond length, it still maintains a higher bond energy because of its higher bond order, right? For 2.6, we are supposed to now say CN has a higher bond order. So we can indicate that that's a triple bond than than CH, which has a what? A single bond, right? So obviously, what does that mean? It means CN requires more energy to break the bonds, right? So CN requires more energy to break or overcome its bond. So hence it ends up having a higher bond energy. Remember, what is bond energy? It is the energy needed to break the compounds molecule into two separate atoms, right? So CN requires more energy to break or overcome its bond, right? So the reason we see a higher bond energy is because of the higher bond order. So remember, the relationship between bond order and bond energy is directly proportional. So the greater the bond order, the greater the bond energy. So with the triple bond, we're expecting that the energy required to overcome those bonds will be higher, right? So I hope that makes sense. Again, it all boils down to those relationships there. Then 2.7 says, explain the difference between bond length of the CH bond and the bond length of the CN bond, right? So we want to tell them CN has a longer bond length than CH because the H atom is smaller than the N atom. This H atom here has a smaller atomic radius as compared to the atomic radius of the nitrogen, right? So nitrogen has a bigger atomic radius as compared to the H atom. Now 2.8, they say, will HCN be soluble in water? Write only yes or no. Write only yes or no. So our solution here, it's supposed to be yes. And then 2.9, explain the answer to question 2.8 by referring to the polarity and intermolecular forces of the compounds. Now, this is where we get to explain. We say the HCN has dipole forces, but then also the H2O has dipole forces. Now we know like dissolves in like. So if we find that the HCN has dipole forces, remember, by being soluble in water, remember, water is that H2O. So by asking the question, will it be soluble in water? It means, will it be able to dissolve in water? So yes, it will be able to dissolve in water because HCN has dipole forces, where else H2O with its hydrogen bond, remember, hydrogen bond is also a package of the dipole forces. So HCN has dipole forces, H2O has dipole forces. Then your last statement, you should say, we know that like dissolves in like. So dipole forces will dissolve in dipole forces. And that's how you are required to explain that for 3 marks. So HCN has dipole forces, H2O has dipole forces. Like dissolves in like. A compound with a dipole force will dissolve in another compound with dipole forces. That's how you were required to answer that question there. So if you have enjoyed the lesson and then you have found it helpful, please press the thumbs up button. And if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.